Sum number 5 is cot cube log of x cube. 1.1 question 2 के फिफ्थ क्वेश्चन में आप सभी का स्वागत है एंड क्वेश्चन नंबर 5 is cot cube log of x cube. विद्यार्थी मित्रों, ये भी एक कॉम्पोजिट फंक्शन है एंड जनरली हम यहाँ पे कॉम्पोजिट फंक्शंस के साथ भी डील करने वाले हैं. तो प्रथम हम कुछ पल के लिए फॉर्मूलाज को रिवाइज कर लेते हैं. ओके, तो जो इस सम के लिए आवश्यक है हमारे लिए. सो फर्स्ट ऑफ ऑल डी बाई डी एक्स ऑफ cot of x is equal to minus of cosec square x. Then we'll say that d by dx of x raised to n is equal to n into x raised to n minus 1. And last but not the least, that is d by dx of log of x is equal to always 1 by x. So always 1 by x. So now let us see. We'll consider let y is equal to cot cube log of x cube. So we need to find out dy by dx, that is derivative of it. And for derivative of the function y, we can give it like d by dx of, and we write the given function for the log of x cube bracket complete. Friends, we can write the given function like this as d by dx of cot of, like this, cot of log of x cube raised to 3. Now definitely these sums look familiar of the type f of x raised to n. So the derivative of it would be this formula where x will be replaced by f of x, and we will take the derivative of f of x any further. Let's move ahead with the sum here. So we will say that derivative of cot of x, first of all we will take derivative of this type x raised to n type here, and we will say that that is 3 cot of log of x cube raised to 2. Further, we need to take d by dx of derivative of cot of log of x cube. So this will become now 3 into cot of log of x cube the whole square. Derivative of cot x is minus of cosec square x, that is here in this case it is a function of log of x2 and cosec square log of x2, so entire x is replaced with log of x cube, and the bracket here, and we'll again take derivative of log of x. Let's take an additional working note here in this case. In this way, say, if we get function like this, so here d by dx of log of x cube, we can certainly write it like 3 into d by dx of x. And we know that d by dx of log of x is 1 by, so we write here like 3 by x, 3 by x. So right here, this, okay. And the final answer here in this case is d by, thus 3 by dx of log of x cube is equal to 3 by x. So this we will certainly, with respect, will substitute certain relative. This is for this to explain in detail. So x cube here. Okay, so 3 by x, that will substitute. Right. So now our final answer here in this case is 3 अभी तक I mean we yet to get final answer, but the structure of the answer is here is quite clear. It's cot square, so here we can write like cot square log of x cube and this minus sign is there in the sum, so we'll write minus sign here and we'll say that 06 square log of x cube bracket complete and d by dx of x2 we have already solved here solution. The final answer now we can certainly say minus 3 by 3 is minus 9 and then log square log of x cube this and then 6 square log of x cube and that would be further divided by 3. That would be further divided by x. So we'll give this answer in a quite a bracket here. We'll write the answer in bracket in a way, like a way of proper representation. The examination also you need to mention properly in bracket. So d by dx of cube log of x cube is equal to minus 9. Here cot square log of x cube into 6 square log of x cube and that would be divided by x. That is a final answer. That is a final answer. So I hope you have got this sum very aptly here. If any step is not clear to you, let me know in the comment box. I will make a separate video or any further explanation is required. I will try to explain it. Thank you. So let's move on with sum number 6 now. Sum number 6 is 5 raised to sine cube of x plus 3. As usual, let's revise the formulas first. So we say that d by dx of 5, or rather say a raised to x is equal to a raised to x into log of a. There is a general formula. So there is a sine function. We'll say that d by dx of sine of x is equal to its cos of x. And also we know the formula d by dx of x raised to n is equal to a into x raised to n minus 1. Knowing this formula in this case is absolutely essential because unless we know formulas very perfectly, we're not able to solve the derivative questions. So now, as usual, the procedure let y is equal to 5 into sine cube of x plus 3 here. So therefore, we'll say that dy by dx is equal to d by dx of 5 into sine cube x plus 3. So this is of a type a raised to x where a is a constant. So if y is a constant and it's a function f of x. So we will consider this formula here. We'll consider this formula. Two separate formulas here. Let me put it into a proper box so that clear understanding of it. So now let's do it like further. So a raised to x log of a. So this will be 5 into sine cube of x plus 3 into log of 5. And this we can certainly solve further taking derivative of sine cube of x plus 3. So this will write here in this case. So that will become 5 into sine cube of x plus 3, then log of 5, and we can take d by dx of sine cube of x plus d by dx of 3 here. The derivative of 3 is 0 because derivative of constant is 0. So here we'll write 5 into sine cube of x plus 3, then log of 5. So it will remain like d by dx of sine cube x, that is also equal to sine x the whole cube plus 0, certainly the derivative of constant is 0. So now if we solve it further, sine cube of x plus 3, this is log of 5. So this will become 3 into sine square of x, sine square of x, and we can take d by dx of sine of x. So here I will write a particular note for this particular part. Say here a big amount of explanation here. So it will be like sine cube of x. We can certainly write as sine x the whole cube. If we take d by dx of sine x the whole cube, d by dx, so certainly let it be as this. By dx of sine x the whole cube is equal to 3 sine x the whole square, which we can write as 3 sine square x, which we can write here. So now let's move ahead with the further aspect of this term, that is 5 into sine cube of x plus 3 log of 5. So this is 3 sine square x, and derivative of sine x is cos of x. So this will become now say 3 sine square x cos of x, then log of 5, and then ultimately 5 raised to sine cube of x plus 3. This answer we need to mention in the bracket always, because that is necessary as for the whole pattern presentation. It's a lot of impact there. Okay. So let me write the answer in the proper bracket at the end. So let's say that d by dx of 5 raised to sine cube of x plus 3 is equal to 3 sine square x cos of x log 5 and 5 raised sine cube of x plus 3. So this is the final answer. I hope all steps are absolutely clear to you. If any explanation is sought after for any particular step, let me know in the comment box. Let's move on to the next sum. Question number 7 is cosec of root of cos of x. So before moving ahead, let's revise the formulas very quickly as per our method. Let me put it into the bracket first, so that we have a clear understanding of the. So first of all, we'll say that d by dx of cosec of x is equal to minus of cosec x into cos of x. Now we have seen in previous sums, so it is a root of x, we write it like root of x. And one more formula, that is d by dx of cos of x is always sin of x. So let us solve this sum now. Let y is equal to cosec of root of cos of x. Root of cos of x. Therefore, we need to take dy by dx is equal to d by dx of cosec of root of cos of x. Root of cos of x. Okay, so let us write it further. So this is equal to d by dx of cosec x. So we will write it again. So d by dx of here cosec of cos of x. So here x has been replaced by root of cos of x. So we have just seen derivative of cosec x in this formula, that is minus cosec of x. So here in this case that is root of cos of x into part of root of x, and then we'll take derivative d by dx of root of cos of x. So that is equal to minus cosec of root of cos of x into part of root of cos of x. Cosec of derivative is 1 upon 2 root of cos of x, referring this formula. And further, we need to take derivative of cos of x. Derivative of cos of x is very simple, that is minus sin of x. So first we'll write it minus cosec of root of cos of x, part of cos of x. So this is 1 upon 2 cos of x, and the derivative of cos of x is minus sin of x. This step here will say that minus minus will become plus. So we'll write it like sin x divided by 2 divided by root of cos of x, and then we'll write cosec of root of cos of x and part of bracket here, part of root of cos of x. So the final answer would be here in this case. Let's put it into proper bracket very neatly. So let's say that d by dx of cosec of root of cos of x. Friends, in Maharashtra state or other anymore, proper presentation is very necessary. So whenever you get your final answer, do not forget to put it into a bracket format. So thus this will become sin of x. This is cosec of root of cos x, then part of root of cos of x, and our answer will be divided by root of cos of x. So that is our final answer. Let's move on to next sum, that is log of cos of x raised to 3 minus 5x minus 5. So here we need to take our formulas. First of all, let's write down the formulas as usual. So I think use another color for writing formulas in this case. So first write down formulas which are necessary for us to solve this sum. So let's write down the formula so that we remember it. So d by dx of log of x is always equal to 1 by x. Another important formula, d by dx of x raised to n is always equal to n into x raised to n minus 1. Derivative of cos of x is minus of sin of x, and d by dx of constant is equal to 0. All these formulas we will require here in this case. So whenever we apply those formulas, let us see, we'll tick mark it into place. Okay. So now let y is equal to log of cos of x cubed minus of 5, x cubed minus of 5. Therefore, we'll say dy by dx is equal to d by dx of bracket here, O bracket, log of cos of x cubed minus 5, x cubed minus 5. So we will move here, in this case, and we'll state that we need to get d by dx of log of cos x cubed minus 5. So this is equal to log of this thing, cos of x cubed minus 5. So log of x is 1 by x. This is f of x as a function of x. So this will first become 1 upon cos of x cubed minus 5 into d by dx of cos of x cubed minus 5. Cos of x cubed minus 5 is like a bracket, square bracket. So this will become then cos of x cubed minus 5. The derivative of cos of x will be minus sine of x cubed minus 5. And further, we need to take derivative of x cubed minus 5. So now, how it will look like? Let us check. So this will be minus sine of x cubed minus 5 um, divided by here it will be cos of x cubed minus 5, and this is d by dx of x cubed minus d by dx of 5. So d by dx. So we have used this formula. We are going to use this formula. This we have already used. Derivative of constant is 0. So we will remember d by dx of x cubed, that is equal to 3 times of x squared. So 3x squared. 3x squared. So our final answer here in this case will be minus 3 into x squared sine of x cubed minus 5, and the whole will be divided by cos of x cubed minus 5. The final answer will be minus 3x squared tan of sine upon cos is tan x cubed minus 5. And as I'm telling you that final answer, we always need to put in the representative bracket format. That is necessity. Proper presentation is very important in the board examinations. So d by dx of log of in bracket cos of x cubed minus 5 are equal to minus 3 x squared tan of x cubed minus 5. This is the answer to question number 8. Let's move on to question number. Next is e raised to 3 sine square x minus 2 cos square x. That is the sum. E raised to 3 sine square x minus 2 cos square x. Let us solve this sum now, but prior to that, we will require the list of formulas which are necessary to solve the sum. Let's make a bracket here. Necessary formulas. Let down the necessary formulas. So let's now write it down. So we know that d by dx of e raised to x is equal to e raised to x. D by dx of sine of x is equal to cos of x. d by dx of cos of x is equal to minus sine of x. And another important formula, always important, that is x raised to n is equal to n into x raised to n. So we will require this formula here also. Let's move ahead with the sum now. So always our first step that we write is let y is equal to y is equal to e raised to 3 sine square x minus 2 cos square x. Cos square x is different now. So we need to write down like dy by dx is equal to d by dx of e raised to 3 sine square x minus 2 cos square x. Put it into a bracket now. So let's write down the answer for this. Say equal to d by dx of e raised to 3 sine square x minus 2 cos square x. So this will become see d by dx of e raised to x is e raised to x, or whether x is basically f of x. So we will further derive it. Means we'll take a derivative of this f of x function, then composite function ultimately. So first of all, we write e raised to x as e raised to x. So 3 into sine square x minus 2 cos square x. Here we'll write d by dx of e raised to 3 sine square x minus 2. Oh, so sorry. Let me check this step once again. Here we need to take derivative of this because the x derivative we have already taken. So it is 3 sine square x minus 2 cos square x. So here we'll write it like e raised to 3 sine square x minus 2 cos square x. And we'll take the derivative of now d by dx of 3 sine square x minus d by dx of 2 cos square x. So now this is equal to e raised to 3 sine square x minus 2 cos square x. D by dx of this will not want a step here, we'll write a step properly here. So that will be 3 d by dx of sine square x. We will write sine x the whole square. So there will be 2 sine x. But we'll not write it directly at this moment. So d by dx of cos square x. So let's solve it simultaneously then. So first, this derivative which we have already found out, note it rightly. And 3 into d by dx of sine square x is basically 2 times of sine of x. And further, we need to take the derivative of sine of x. Then we'll again say 2 into d by dx of cos square x is basically 2 times of cos of x raised to 1 raised to 1. But we need to take the derivative of cos of x. So what this will turn out will be, let us see, that is sine square of x minus cos of square of x 2 into cos square of x. So that will be 3 into 2 sine x into derivative of sine x is cos x minus 2 into cos x, and derivative of cos x is minus sine x. And here we will write e raised to 3 into sine square of x minus 2 cos square of x. So this is like 3 into 2 sine of x into cos of x. This minus minus will become plus, and we'll write it like 2 times of sine of x into cos of x. So 2 sine x cos x basically we need to this particular part is common. This can be given sum. So this is actually I will tell you sine of 2 theta. Sine of 2 theta is basically 2 sine theta and cos theta. So this is 3 times of sine of 2x plus 2 times of sine of x. So ultimately this will become 5 times of sine of 2x raised to like 3 sine square x minus 2 square x. Okay. And question is d by dx of the derivative of e raised to 3 sine square x minus 2 cos square x. So answer is this. Let me put it into bracket. So this answer that bracket, and this is the solution for question number 9. Let's move on to question number 10. If you have any doubt in any particular step, just let me know. I will give a reference note in a further video. Let's move on with question number 10. Question number 10 is cos square log in bracket x square plus 7 x square plus 7. So in this sum, we need to note down the important formulas which are required to solve this particular sum. Let us write down the formulas which we require in this sum. So d by dx, first of all, x raised to n is equal to n into x raised to n minus 1. D by dx of log of x function is x is 1 by x, and d by dx of cos of x is equal to minus sine of x, and always derivative of constant term. Here constant is 7 in our sum, so that is equal to 0. Let us now solve the sum. So we write here let y is equal to cos square, then log of x square plus 7. So here we will say that dy by dx of d by dx of, see this cos square, we can write it like cos of log of x square plus 7 square bracket here. It's a curve bracket, I think square bracket here. This particular part, square bracket, square. So we will write here further like equal to d by dx of cos of, the bracket is in the sum they have given square bracket, so we will not change anything in respect of that. And we'll put our bracket from our side, this bracket, curve bracket, and this formula is of this kind now by finding out the derivative. So that will become 2 times of cos of log of x square plus 7, log of x square plus 7. With this aspect x raised to n we have completed. Then we need to take derivative of this function cos of log of x square plus 7. X square plus 7. This is a curve bracket, there is a square bracket. So that clarity, so x square plus 7. So it is like this. So now this will become 2 into cos of log of x square plus 7, that will complete. Derivative of cos, as we are right on the left side, derivative of cos is minus sine of square bracket itself log of x square plus 7, and then we'll take derivative of x square plus 7. Derivative of x square is 2x, and derivative of 7 So 0 is a constant. So one of the formulas we have. Oh, but I think prior to that, we also need to take derivative of log of course. So this part remained. So that we write as d by dx of log of x squared plus 7, and then we need to take derivative of x squared plus 7. So we will write the step again, that is cos of log of x squared plus 7. Okay, there's a minus sign here, we'll write this minus sign here. Then sine of, this is log of x squared plus 7. We'll take derivative of this first because log of x squared plus 7, we are using this formula here, this very formula here. X is 1 by x. This function is log of x squared plus 7. So eventually this will turn on to 1 upon x squared plus 7. 1 upon x squared plus 7. And derivative of x squared plus 7 is 2x. Derivative of 7 is 0. So plus 0 is 2x. Ultimately, this will become minus 2 into x into 2 times of sine of log x squared plus 7, then cos log of x squared plus 7, and the entire thing will be divided by x squared plus 7. That thing will be divided by x squared plus 7. Okay. Why I have separated this two sign part? Because we'll write a separate note here. Box like inside, inside of the required formula. That is basically stated it is 2 times of sine theta into cos theta. That we write as sine of 2 theta. Sine of, check here, this is 2 to sine theta. So theta is log of x squared plus 7, and this is cos of theta. So ultimately we can write like this here, minus 2x, and that would be certainly divided by x squared plus 7, divided by x squared plus 7, and this is sine of 2 into log of x squared plus 7. We can write answer like this ultimately. So this is what the answer is. As I told you, we need to write the answer in the proper format. So let's make a box here and write the answer in a box with the proper way of representation is very necessary in the board examination. So that will be d by dx of cos square of log of x square plus 7, that is equal to minus 2x sine of 2 theta. So that will be log of x square plus 7, and bracket complete. And that would be divided by, as it was x square plus 7, x square plus 7. So that is the answer. I hope each and every step is clear to you. Sum number 11 is tan of cos of sine of x. So 3 trigonometric major functions are there in the sum. As usual, we will first note down the required formulas, and writing down formulas makes us less susceptible for any error in the process of solving the sum. So we can also cross check where we have not use the relative formula which we have thought of earlier. So 6 square x, and therefore just a second. D by dx of cos of x. Cos of x is equal to minus sine of x, and d by dx of sine of x is equal to cos of x. So this all formulas are very essential for us in while solving the sum. So as usual, we'll first write let y is equal to tan of cos of sine of x. This is in the square bracket or curly bracket, so curly bracket. Let me write it properly. It's again. So cos of sine of x. Yes. Now we need to take a derivative of it. So dy by dx is equal to d by dx of tan of square bracket. This is given in the square bracket. So we will follow this. Cos of sine of x. Cos of sine of x. So therefore, we'll say that dy by dx is of, say, d by dx of tan of cos of sine of x. So we know that tan derivative is sec square x. So that will become sec square of cos of sine of x. So this aspect is over. Now we need to deal with cos of sine of x. So there we will write d by dx of cos of sine of x first of all. So let's solve this. So this will become sec square of cos of sine of x, and derivative of cos x is minus sine of x here in this case, and then we need to take derivative of sine of x further. So this will become now minus sign is there in the sum. So minus sec square cos of sine of x. Then again sine of x, and derivative of sine x is cos x. I think that is our final answer. So we will write d by dx of tan of cos of sine of x is equal to minus sec square cos of sine of x into sine of x into cos of x into cos of x. So we need to write it like this. This is a final answer for some determinant. I hope all steps are very clear to you. In case of any query, please write in comment box, and I will make a separate video for it to make this. So sum number 12 is sec of tan of x raised to 4 plus 4. Sec of tan of x raised to 4 plus 4. So let us solve this sum. First, we will write down all the necessary formulas which are essential for the operations in this sum. So we'll say that d by dx of derivative of sec x is equal to sec x into tan x. Derivative of tan x is going to be that is sec square of x. D by dx of x raised to n function is always n into x raised to minus 1, and derivative of constant is equal to 0. So let's solve this sum. Y is equal to, let y is equal to this fashion. So let y is equal to sec of tan of x raised to 4 plus 4, and then let's say further that therefore we will find out dy by dx. So dy by dx is equal to d by dx of sec of tan x raised to 4 plus 4. Now that is equal to sec x is derivative of sec x is this sec x tan x. So we'll write it like, let's write down the step first. Like moving in front of your eyes this particular solution. So we'll write the step once again. So sec tan of x raised to 4 plus 4. Now this is equal to sec of x, derivative of sec of x is sec x, tan x. So here sec of f of x, so sec of f of x, so tan of f of x, and derivative of f of x will take. So derivative of sec x is now sec of tan of x raised to 4 plus 4, and sec x tan x, so tan of then tan of x raised to 2 plus 4. Then we'll take d by dx of tan of x raised to 2 plus 4. So now this will become sec of, we need to write it properly all the time, 4 by 4 plus this is tan of x raised to 4 plus 4. Derivative of tan is theta. Derivative of tan of x is basically 6 square x. So it is 6 square of f of x, and then we'll take function derivative of function f of x. So now this will be tan theta, derivative 6 square theta. So 6 square x raised to 4 plus 4. And then we'll take derivative of x raised to 4 plus 4. So now this will become sec of tan x raised to 4 plus 4 tan of x raised to 4 plus 4. Then sec square x raised to 4 plus 4, and this is 4x cube, derivative of 4 is 0 because it is constant. So apply the whole this which we had thought earlier with the right. So this sum. Let us see now how we did place it. We'll write 4x cube into sec square x raised to 4 plus 4 sec of tan x raised to 4 plus 4 tan of this bracket tan of x raised to 4 plus 4 here. And that is our final answer, and as we have discussed always, your final answer is need representation. Proper representation is very necessary. So this will become d by x of sec of tan of x raised to 4 plus 4 is equal to 4x cubed sec square x raised to 4 plus 4 sec of tan of x raised to 4 plus 4 and tan of tan x raised to 4 plus 4. So that is our final answer. That is our final answer. I hope you have understood this, and also you have understood each and every step that we need to follow in this sum. Okay. So we'll meet once again with sum number 13, sum number 18 in the next video.